So we've learned how to calculate the area of different shapes. Now what we're going to do is we're going to put those shapes together and we're going to figure out the area of what are called composite figures. Composite just means made up of multiple parts. And so there's two types of problems we're going to do here. One type of problem is we're going to take several different shapes and we're going to figure out what the total area there is. So like if the area of this rectangle was 8 and the area of this triangle was 3, the combined area of those two composite figure, right? In other words, the combined area of those two shapes would be 11. The other type we're going to do is we're going to start with a shape like this rectangle, but then we're going to take something away from it. So let's say the area of this whole rectangle right here is 10 and the area of this circle is 2. The composite area, it's like we punched a hole in that rectangle. If we have 10 minus 2, the composite area there would be 8. So we're either going to be adding the area of two shapes together or subtracting the area of one shape from another one, depending on what the problem says. Okay, so here's an example. I have this composite figure here. I can see that I have like half of a circle, I have a regular hexagon, and then I have a trapezoid. And so the way to do this is just to do each shape separately, and then at the end we'll add them together. So the first thing I'm going to do is the semicircle. Okay, so what do I know about it? Well, I actually have to look at the hexagon to get any information. The picture here is showing that each side in the hexagon is 9 centimeters. So what that tells me is that this right here is one of those sides. So it's 9 centimeters. So the diameter of the circle, right, is 9 centimeters. The formula for finding the area of a circle is pi times the radius squared. So I know the diameter is 9, and I know the radius is just half of whatever the diameter is. So since I need r for the formula, I have to figure out what the radius is. Like I said, the radius is just half of that. Half of 9 is 4.5. So now I can plug that into my formula here. I'm going to have the area is equal to pi times 4.5 squared. So there's my 4.5 squared. Now I'm just going to multiply that by pi. Okay, so the area of the whole entire circle, like if I kept this circle going, would be 63.61, or it's actually 63.62 if I'm rounding. So that would be the area of the whole circle. But as you can see, I only have half of the circle. So I'm going to take this and I'm going to divide it by 2. I'm going to cut it into 2 equal parts, because all I want to know is this. I don't want to continue the circle out because I don't have the whole circle. So I just want to know half of it. So I'm going to divide that by 2. And I get 31.8. So that's one of the areas I had to find. Now I'm going to find the hexagon. The area of the hexagon. Okay, so the only thing I know right now is that each side in the hexagon is 9 centimeters. So what I have to do is I have to draw a triangle in here. I'm going to have to figure out the area of one of these triangles, and then I'm going to multiply it by 6 because there are 6 of these triangles inside of the hexagon. So let me just draw one of the triangles over here. And what I really want is this line, which is called the apothem. I know that this side down here is 9. And I know that by drawing in the apothem, I sort of split that triangle into 2 equal parts. The only thing I know is down here is 9. Well, what that also tells me is that this would be 4.5 and this would be 4.5, right? The apothem basically bisects this base of the triangle. The other thing I know is that if I were to draw a circle around the hexagon, there'd be 360 degrees in it. So what that means is that each one of these triangles has 60 degrees, right? Because if I take 6 times 60, I would get 360. So each one of these triangles, if I draw an angle here, that black angle would be 60 degrees. What that means then is that if I just split off this triangle, this angle up here is going to be half of 60, which is 30 degrees. So I know that angle is 30 degrees. I know this piece down here is 4.5, so now I can use a trig ratio to figure out what the apothem is, what I'm going to call x for right now. So here's the angle I'm working with. The side opposite of my angle is 4.5. And x, which is the one that I want to know, is adjacent. So when I'm working with opposite and adjacent, it's a tangent. So the tangent of my angle, which is 30, equals the opposite over the adjacent. So what's the tangent of 30? 0.577. And now to get that x out of the denominator, multiply it by x on both sides. So I have 0.577x equals 4.5. Divide both sides by 0.577 to get x by itself. And so the apothem here is going to be, I'm just going to call it 7.8. Okay, so this side over here is 7.8. Now I know for my triangle here, going back to this one, I know that this is 7.8. I know the base of this whole triangle, so I'm back to the whole triangle now. I know that the height is 7.8. I know that the base is 4.5 plus 4.5, or 9. So now I can figure out the area of that one triangle. So the area of the triangle is base times height over 2. So that would be, in this particular triangle, that would be 7.8 times 9 over 2. And actually put those in the wrong place. The base is 9, the height would be 7.8. It doesn't matter which order I put those in, I just don't want to confuse you. So now to figure out the area of one of those triangles, it's 9 times 7.8 divided by 2. So 9 times 7.8 divided by 2. Okay, so the area of this one triangle is 35.1. Okay, but I don't want to know just the area of one of those triangles. I have 1, 2, 3, 4, 5, 6 triangles. So I have to take that 35.1 and multiply it by 6. So the area of the hexagon is 35.1 times 6. So 210.6 is the area of the hexagon. Alright, now I'm going to figure out the area of this trapezoid. This one's going to be easier than the other two. Quicker, at least. The bases of a trapezoid are the two sides that are parallel to each other. And so I can sort of see that this top side and this side are not parallel, right? They're obviously going in different directions. If I kept them going out this way, they would eventually run into each other. So the two bases are this side and this side. So the area of this trapezoid, if I want to solve for the area of a trapezoid, it's the height times base 1 plus base 2 divided by 2. So the area of this trapezoid is the height, oops, the height of this trapezoid is going to be this one, right? The height is the distance between the two bases. So it's going to be 19 times 9, which is this base right here. How do I know that's 9? Well, if you remember, each side of that hexagon is 9. The other base is 15. And then I'm going to divide all that by 2. So 9 plus 15 is 24. So I'd have 19 times 24 divided by 2. And I'm just going to do that all at once here. So 19 times 24 equals that divided by 2. So the area of the trapezoid would be 228. Okay, so now I know the area of all three of those parts, and I just need to add them together, and that's my answer. So I have 31.8, 210.6, and 228. $470.4. So because of rounding, my answer might not match anything exactly. Yeah, it's obviously closest to this one. So due to rounding, we were 0.2 off, but D would be our answer for this one. So here's another example of a composite figure, calculating the area of a composite figure. So it says Ignacio's family is getting new carpet in their family room, and they want to determine how much the project will cost. So here's their family room over here, and you can see it's made up of two shapes. One is this rectangle here, and then there's also like a trapezoid on top of it. So what we're going to do is we're going to calculate the area of the rectangle, and then we're going to calculate the area of the trapezoid, and we're going to add them together, and that's going to tell us how big the living room is. Okay, so the rectangle is going to be pretty easy. I can see that one side of the rectangle, first let's write down the formula. For a rectangle, it's just base times height, or you could say length times width. So I'm going to call this 24 the base, and now I just need to figure out like the height. Well, it says the whole thing is 17 feet wide, but I only want to know from here to here for this rectangle. So what do I do? Well, I can see that this length right here is 6. So if I just want to know this length right here on the side, that's just going to be 17 minus this 6, right? This whole length is 17. 6 of it's right here, so what's left for this? Well, it's going to be 17 minus 6, which is 11. So this length right here is 11. So the area of the rectangle is 24 times 11, which is 264. So that's for the rectangle. Now I'm going to do the trapezoid. And I already have all the information I need to do the trapezoid. So the area of the trapezoid, remember, is the height times base 1 plus base 2. And I'm going to divide all of that by 2. So the area of the trapezoid, the height is this 6 right here, right? Because here's one of my bases, here's the other base, right? Those are the two sides of the trapezoid that run parallel, so those are my bases. The distance between those two bases, it tells me here, is 6. Okay, so one of my bases is 9, the other base over here is 24, and the reason I know that is because this side is 24, and that's a rectangle. Opposite sides of a rectangle are congruent. And then I'm going to divide that by 2. So the area of the trapezoid part of the room is going to be 6 times 9 plus 24, which is 33, divided by 2. So the trapezoid is 99 square feet. So the area of the room altogether is just going to be that 264 from the rectangle plus the 99 from the trapezoid. So 363 square feet. That's the area of the entire room. So that's part A. Part B says if carpet costs $4.86 per square yard, how much will the project cost? Well, you'll notice they're using different units now. So what we have to figure out is how many square feet are in a square yard. Okay, so a square yard, I'm going to draw it down here. If you know what a yardstick is, you'll know that a yard has 3 feet in it. So if I have a square yard, that means I have 3 feet here, 3 feet here. So in every square yard, they're actually going to be 9 square feet, right? Here's 1 yard. Here's 1 yard. If I square the yard, right, every yard has 3 feet in it. If I square 3, I get 9. So 9 square feet in every square yard. So I need to take this 363 and I need to figure out how many square yards it is. Okay, so there are 9 square feet in every square yard. So if I take that 363 and divide it by 9, this will tell me how many square yards I have. So I only have 40.34 square yards, and it's $4.86 for every square yard. So I want to know how much, or if Ignacio's family wants to know how much this project's going to cost, I'm just going to multiply that $4.86 by the number of square yards that I need. $196. For this next one, we're going to calculate the area by subtracting. In other words, we're going to see what's left over after we punch a hole in some shape. So let me draw this again to kind of try and show you what we're doing here, in case that doesn't make sense. So I have this parallelogram, and it starts out looking like this. So the first thing I'm going to do here is I'm going to calculate the area of this parallelogram as though there weren't a hole punched in it. And so the information I have over here is that the height is 9 feet and the base is 14 feet. So remember, if we're calculating the area of a parallelogram, it's just like the formula for calculating the area of a rectangle. So the area of the parallelogram is just going to be 14 times 9. Base times height. So the area of the parallelogram, if there wasn't a hole cut in it, would just be 14 times 9, which is 126. Okay, that's if I just had it like this. But then you can see what happened is a kite was cut out of it. All right, so I have this kite. And that's not perfect or even close to it, but hopefully that helps you see what's happening here. I started out with the whole parallelogram, and then I cut this kite out of it. So what I need to do is figure out how much blue would be left after I cut this kite out. To do that, I'm going to figure out how big the kite is, how much area is in the kite itself. So the formula for figuring out the area of a kite is I multiply the 2 diagonals together, and then I divide that by 2. So the diagonals of this kite, one of them would be from right here to right here, and one of them is from right here to right here. Well, this long diagonal is going to be the same as the base, right? Because everywhere along this parallelogram, that side is going to be the same, right? Down here would be 14, the top is 14, so that means that this diagonal is 14. And this diagonal here is just going to be 9. It's going to be the same length as that. Okay, the only difference between the formula for calculating the area of a kite and that for calculating the area of a parallelogram is that when I'm doing a kite, I have to multiply the 2 numbers together and then divide by 2. So I already know that 14 times 9 is 126. Now I'm going to divide that by 2. So the area of my kite is going to be 63. So the parallelogram is 126, the kite is 63. What I want to know is how much blue is left after I carve that kite out of there. So it's going to be the big number, 126, minus the smaller number that I cut out of it. And so it's kind of obvious what I'm going to get here. I'm going to get 63. So the answer here is the area of this parallelogram after that kite has been cut out of it. Area of the composite figure, in other words, 63 square feet. So here we have a basketball court, and part of it's painted red, part of it's painted blue. And it wants us to figure out what's the area of the red, what's the area of the blue, and then we'll move on from there. Okay, so the area of the red and the blue, you can kind of see where each one is. I'm actually going to do the red first because I think it's going to be a little bit easier if I do it that way. the red part of the court is this circle right here, the same one down here, and then this one right here, but I can't use the whole entire area of this circle because there's a blue piece inside of it. So what I really want on this center circle is just this ring here, sort of. Okay, so let's do that step by step. First thing we can do is figure out the area of these red circles, basically that contain the free throw line. The way I'm going to do that is by using this diameter right here. It's telling me that it's 12 feet from here to here. That's the diameter of the circle. So to figure out the area, I'll do this in red. Figure out the area of this circle. It's pi r squared. Right now what I have is the diameter. And remember, the radius is just half of the diameter. So the radius for these red circles is just going to be 6. If the diameter is 12, radius is 6. Okay, so the area of the circle is pi times that radius squared. So the area of the circle is 36 times pi, which is 113.1. So that's the area of one of these red circles. But as you can see, I actually have two of them. So I have a 113.1 plus a 113.1, right? Here's 113.1. Here's another 113.1. Now I'm going to try and figure out what the area of this ring is. But to do that, it's going to take a couple of steps. So I know that basically this whole circle would have the same area as both of these circles that I already found. So I'm going to start with 113.1, but I'm going to subtract the area of this little blue circle inside of here. Okay, so let's figure out what the area of that little blue circle is. Well, its diameter, it's showing us here, in other words, from right there to right there, is 6 feet. So the diameter is 6, radius is half of that, so 3. So to figure out the area of the little blue circle, I'm going to say, okay, well, pi times 3 squared. I know 3 squared is 9, so I just need to know 9 times pi. 28.3. Okay, so the area of the little circle is 28.3. So to figure out the area of the red inside of this circle, I'm going to take the 113.1, which I know the whole thing would be, and I'm going to subtract this 28.3 from it. $84.8. So the last piece of red that I have on the court is this ring right here, which is 84.8. So the total area of red on the basketball court is this circle, which is 113 plus 1.1, plus this circle, which is also 113.1, plus this red ring in the middle circle, which is 84.8. So I just need to add those three together. 311. That's the area of all the red on the basketball court. Now I need to finish up with the blue. So I already know part of the blue is this 28.3. That's this little circle inside of here. Now I need to know basically what the lane is on both sides. So what I have on both free throw lanes is I have something like this. I have a blue rectangle. Oops. I have this blue rectangle, but this semicircle's been cut out of it, right? Half of one of those red circles is cutting out of that rectangle that I would otherwise have in all blue. So let's figure out what the rectangle would be if it were all blue, if this whole thing were blue. Well, this side is 19, this side is 12. So the area of the rectangle would be 19 times 12. So 228. But remember, I have to kind of shave off this semicircle right here. That's actually red. All right, this part's actually red, so I'm gonna have to cut that part out. Well, luckily I already know that each one of those circles, the whole thing is 113.1, and I want half of it. Right? I want to take half of one of those circles. So 113.1 divided by 2. 56.6. Right, so I had this whole rectangle, but then I'm going to cut a semicircle of red. The way I know that how much area this semicircle takes up is to divide what the whole area of the red circle is by 2, and that's 56.6. So each one of the lanes is 228 minus 56.6. which is, I don't know why I wrote that again, 228 minus 56.6. 171.4. And remember, I have two of them, right? I have this one over here, that's 171.4. I have this one over here, that would be exactly the same. So the area of blue, so I'm going to have 171.4 for this free throw lane on the right. I'm going to have 171.4 for the free throw lane on the left. And then I'm going to have 28.3, which remember is this little part of the circle in the middle of the court. So I just need to add those three together. So 371.1. That's the area of the blue on the basketball court. So a little bit more blue than red. Last example for composite figures. I have this image here on the coordinate plane. That's going to make it really easy to figure out the areas here. What I'm going to do to start is pretend that I want to know the area of this rectangle ABCD. All right, so I want to know the rectangle. I'm just going to pretend like nothing's been cut out of it. I'm going to start from there. That's going to be pretty simple. I need to know the length and the width, or the height and the base. This side here is 4. This side here is 1, 2, 3, 4, 5, 6, 7, 8. 4 times 8 is 32. So the area I'm going to start with is 32. I'm going to take that 32 and I'm going to subtract this right here and this right here from it. Okay, so I'm going to subtract the semicircle, and then I'm going to subtract this right here, which is a trapezoid. That's going to tell me my answer of how much area this yellow shape takes up. All right, let's figure out the area of the semicircle up here. I can see that its diameter is 4. So its radius then is 2. Right? Area of a circle is pi times the radius squared. So it'd be 4 pi. 4 times pi is going to be 12 point something. 12.57. Okay, but I don't want to know the area of the whole circle because I'm not cutting a whole circle out of this shape. I'm just cutting half of that circle out. So what I need to actually know is, what is that 12.57 divided by 2? It's going to be 6.28. Okay, so the area of the circle that I'm cutting out, or the semicircle, is 6.28. Right? I didn't cut a whole circle out of here, I just cut out this half of a circle. Okay, now I need to figure out the area of this trapezoid that I cut out. The area of a trapezoid is the height, which, if I erase my shading here, I can see that from this base to this base, the distance between those two is 1, 2, times base 1, which is 2, plus base 2, which is 1, 2, 3, 4, and then I divide that by 2. So 2 plus 4 is 6. 6 times 2 is 12, divided by 2 is 6. So the area of the trapezoid here is going to be 6. So now all I need to do to get my answer to how much area this yellow shape takes up is take 32 and then subtract 6.28 and then subtract another 6. So the area of the yellow shape would be 19.72 units.